Lesson 12.8, motion problems with trig level 2. Determining if speed is increasing or decreasing at a given time. I wanted to make a little note for you. We've talked about this. To find or to determine if speed is increasing or decreasing, we have to know the velocity and the acceleration. If they have the same signs, meaning they're both positive values or they're both negative values, then the particle is speeding up. But if they have opposite signs, where one's a positive, one's a negative, then the particle is slowing down. So that should sound familiar to you. So we're just going to apply that in this problem that has trig values. It says a particle moves along the x-axis with an acceleration. So we have an acceleration for times greater than or equal to 0. If the particle has velocity of 2 at time of 4, determine if the speed is increasing or decreasing at a time of 8/3. So what we would want to do is maybe first even just find acceleration before we anti-derive. So let's say we want to find the acceleration at the time of 8/3, because we're going to have to know that as well. So I'm going to have 5 pi over 4 times sine, we're not changing anything, we're just plugging in, pi over 4 times 8/3. We're evaluating. So I would cross simplify my 4, my 8. So that's really 5 pi over 4 times sine of 2 pi over 3. Again, I can think of, this is a pi, or 180 degrees divided by 3, that's your 60. So 2 60s is a 120, but either way I know sine is positive when it's in quadrant 1 or 2 because it's a y value. And sine of 60 is my square root of 3 over 2. So I can see right here at 2 pi over 3, my y value is a positive square root of 3 over 2. So I'd have 5 pi over 4 times square root of 3 over 2, which I can't simplify anything. It's just 5 pi square root of 3 over 8. But what that tells me is that it's positive. So that is half of my calculating that I need to do. Now I'm going to find velocity. So I'm going to have to anti-derive my 5 pi over 4. 5, maybe I can change that into a pi symbol. 5 pi over 4 sine of pi over 4 t with respect to time. So I'd have 5 pi over 4. And then I think antiderivative is cosine. What's the derivative of cosine? Negative sine. So I'm going to have to make that a negative to make up for that. Then I'll keep the pi over 4t. But then I'm going to have to divide by pi over 4 or times 4 over pi and plus c. Pi's cancel, 4's cancel. I get negative 5 times cosine pi over 4t plus c. And this is for my velocity. And then they tell me that there's a velocity of 2 when t is 4. Fours are going to cancel. I'm really finding cosine at pi. Remember, pi is 180 degrees. The x value there would be negative 1. So I've got negative 5 times negative 1. That's 5. Subtract 5. C is going to equal negative 3. All right, so now in velocity, I'm wanting to plug in my 8/3. My function is the negative 5 cosine of pi over 4 times 8/3 minus 3. 4 and 8 can cross simplify. Negative 5 cosine of 2 pi over 3 minus 3. Cosine at 2 pi over 3, that's the x value, that's negative 1/2. So I'm doing negative 5 times negative 1/2 minus 3. That gets positive 5/2 minus 3. We really don't even care about the value, we care about the sign. 5/2 is really 2.5. If I take 2.5 minus 3, that's going to get a negative half. So I had a positive and a negative. That means that the speed of the particle is decreasing. So it's a lot of work just to find that out. All right, number 2, the same exact process, just the wording different. They're asking you if a particle is moving towards or away from the origin, which to me the origin is weird. I would think more away or towards the x-axis is what I'm thinking. I guess because the origin is where, you know, you think of the bunny hopping, where the bunny started and then he went to like the right or the left, I guess. His origin was a starting point. But what you're needing to know is that you're comparing position and velocity now. So if the position and velocity have the same signs, then it's moving away from. Kind of like in my mind thinking speeding up was always moving away from the origin. If a position and velocity have opposite signs, then it's moving towards it. It's like it's slowing down. That's how I can remember it. So we've got a velocity function. And then we have to antiderive that to get the position function. So from velocity, we could go ahead and plug in our time of 10. Cross cancel, 10 divided by 5 would be 2. So it's 4 pi over 5 times cosine of 2 pi. 2 pi is all the way around, so that's here. That ordered pair would be 1, 0, and we want the x value, so that's 1. So we get 4 pi over 5 times 1, which is positive for velocity. All right, then I would want to antiderive 4 pi over 5 times cosine of pi over 5t. Respect to time, 4 pi over 5 sine, which is fine, right? Derivative of sine is just cosine, so no negative. Pi over 5t, divide by pi over 5 or times 5 over pi. Pi's cancel, 5's cancel. 4 sine pi over 5t plus c. And that is your position function. Plug in your x and your t. Again, I like when the time is 0, so that makes that 0. Sine at 0, that's the y value over here, so that's height of 0. So that's all 0. C would equal -1. So I'm going to plug in a time of 10 to see what our value is, whether it's positive or negative. So 4 sine pi over 5 times 10 minus 1. That's 2 pi. Sine at 2 pi is the same value, that's 0. Times 4 is 0. So we get 0 minus 1 is a -1. So that's negative, that's positive. We would say we're moving towards the origin. That's it.